Hey guys, and welcome back to another lesson on standard index form. I hope you joined us for our previous lesson on standard index form, because today we're taking it one step further as we multiply and divide values which are in standard index form. If you missed our previous lesson, check the description box down below. I'll link it for you there. But if you've seen it and you're ready to get started, let's do it. You should already know that standard index form helps us to see the place value of a digit. So for example, here I've got 4.2 times 10 to the power of 6. That tells me that the decimal was shifted 6 places, which means the 4, which was in the units position, ends up in the millions position. And I've got 6 place values after that 4. Similarly, when we've got negative indices, the decimal place is shifted again, but this time my number is getting smaller. Since the decimal was shifted 3 places to the left, the 1 that was in the units position ends up in the 3rd decimal place. That's 1, 2, 3 digits after the decimal point. So from the place value point of view, this makes multiplying and dividing values together even easier in standard form than in normal expanded form. Since standard form involves base 10 index terms, a knowledge of multiplication and division laws for laws of indices will be necessary for this. If you haven't learned that before, again, check the description box down below and I'll link some lessons there for you. So here I'm multiplying 4.2 times 10 to the power of 6 times 1.1 times 10 to the power of negative 3. And I am not going to expand these values out, although we've already seen them expanded out previously. What we're going to do is we're going to multiply together the non-base 10 parts, so 4.2 times 1.1, and then we're going to use laws of indices to multiply together the base 10 parts. Obviously, they have the same bases. 10 to the power of 6 times 10 to the power of negative 3. The multiplication law tells me I could add those indices together. So first doing 4.2 times 1.1, do some long multiplications if you need to, or if you really must, you can use a calculator. That's 4.62, but there's no excuse for using a calculator to work out 10 to the power of 6 times 10 to the power of negative 3. It's simply 10 to the power of 6 plus negative 3. And adding a negative is the same thing as subtracting, so that's 4.62 times 10 to the power of 6 minus 3, which is 3. So there's my answer in standard form. And I hope you found that relatively simple. I could try to work that out in the expanded form, but I get nervous just looking at that. I know that 4,200,000 times 0.0011 will be equal to 4,620, because in standard form, all I need to do is move that decimal 3 places. So the 4, which was in the units position when this was in standard form, shifts over 3 places into the thousands position. So 4,200,000 times 0.0011 is 4,620. We can do this with divisions as well. However, I much prefer to write my divisions as fractions, because that makes it a lot clearer which values need to be multiplied and which values need to be divided. So I'm doing 2.8 times 10 to the power of negative 4 divided by 1.4 times 10 to the power of negative 3. As I did before, I can do the division of the non-base 10 parts, so 2.8 divided by 1.4, and then I'll multiply that answer to my solution from the division of the base 10 parts. For that, of course, I'll be using my laws of indices again. I've got the same bases, and when I'm dividing two terms with the same base, I can subtract their indices. But first, working out 2.8 divided by 1.4, that's simply 2. And I'm multiplying that by 10 to the power of negative 4 minus negative 3. Now, a double negative, you should know, means add. So that's going to be 2 times 10 to the power of negative 4 plus 3. And negative 4 plus 3 is negative 1. So there's my answer in standard form once again. And if I want to write that in expanded form, that would simply be 0.2. Because of course, a negative 1 index means shift the decimal, but simply 1 place to the left instead of the right. So the 2 that I had in the units position has simply shifted over 1 place to the tenths position, or to the first decimal place. Therefore, in expanded form, I could say that 0.00028 divided by 0.0014 is equal to 0.2. But I wouldn't even attempt this in long division. I'd much rather do this in standard index form. How about you? So if you've got that, let's go into the practice exercise now. For question 1, these are all divisions. I would much rather you write them as fractions first. And then again, remember, we do our non-base 10 part divided by our other non-base 10 part, but then we multiply that by the base 10 part of our value. And remember, the division law tells us to subtract the indices. For question 2, you've got some multiplications and divisions involved here. We'll work this through in the same way. First, multiply together the non-base 10 parts that are in the numerator and divide that by the non-base 10 part that's in the denominator. And then, with your base 10 parts, use laws of indices to multiply the two base 10 parts in the numerator and divide that solution by the base 10 part in the denominator. Go ahead and hit pause now so that you can do that. You can use a calculator if you really must, but make sure you're showing the working and you're not relying on the calculator to do the whole thing for you. So go ahead and hit pause, work that through as best you can. Make sure that your answer is in correct standard form, and I'm emphasizing correct standard form. Maybe you want to take a look at your note on standard form to remember what that means. And push play when you're ready to take it out. I hope you've had a chance to hit pause, because here come your answers. For question 1A, I've written these as fractions. As you see, I grouped together my non-base 10 parts, and I'm multiplying that by the solution of my base 10 parts. And I've left my answer in standard form. Question B, again, working in fractions here. And again, my answer in standard form. Question C, notice my rounded symbol there. 1.31 is correct to 3 significant figures. D and E. On to question 2. For A, but that's not standard form. No, standard form has to be some value between 1 and 10 multiplied by some base 10 value. 11.685 is not a value between 1 and 10. So if I'm going to shift that decimal place one place over, I need to multiply that by an extra 10 to put the decimal place where it belongs in the expanded form. For question B, question C, again, that's not standard form. 32 is not a value between 1 and 10. So to make that 3.2, I'll then have to multiply that by an extra 10, so 3.2 times 10 to the power of 10. Question D. Again, that's not in standard form. I hope you checked that for yourself. If you want to correct it before I put the answer up, please do. It's 1.8 times 10 to the power of 12. Now, how did you do with that? Are you ready for an extra challenge? I hope you weren't just using a calculator on this, because check out the kinds of questions you could see on a GCSE exam. Given that A times B is greater than 10, express the following in simplified standard form. And given that C is less than D, express these ones in standard form. Make sure you remember that correct standard form is a value between 1 and 10 multiplied by 10 to some integer value, that is some positive or negative whole number value. Go ahead and give yourself a challenge, give that a try, and look out for my next video if you want to take up the answers with me. I hope you found this lesson interesting and helpful. Until next time, keep practicing, and I'll see you soon.